Okay, so we're going to start off with a nice easy one here. General kind of introduction to the circle. We're going to look at the equation of a circle. So like the equation of a line, we have specific ways that we write the equation of a circle. We actually kind of again have maybe two, I suppose, most common ways that we would put the equation of a circle. So one of them being equation of a circle with center HK. So we refer to our center as H and K, and then we have a specific format that we write the equation in. And that format, I suppose, is given to you here on the right hand side. So you can see with center HK, I can put x minus h, y minus k. So noting that means that should we have a center that was, say, -2, -3, for example, then this would become x plus 2 squared and y plus 3 squared. Okay, so kind of noting how that would change depending on the signs of h and the sign of k. We also then, of course, have the radius at the end, and it's r squared, where r squared is our radius squared. Okay, we have a specific, I suppose, version of that as well for a center 0, 0, which you can see on the left-hand side here, which of course is just x squared plus y squared, and that just comes from the fact that the center is just 0, so we kind of remove that minus h minus k part. The last thing to note really with this sort of format for the circle is just that it has to be 1x squared plus 1y squared equals r squared. Generally, that's the format we would write it in. We may extend, we may multiply things out as well, but typically we kind of go with 1 and 1, and then our r squared at the end for our radius. And I suppose if we were to alter that, it's just to note that we would need to reduce it back to this format in order to go with, okay, well, this is what the radius is. So if I had, say, 2x squared plus 2y squared equals 8, well, then my actual circle is x squared plus y squared equals 4, where 4 is the radius squared, as opposed to 8 being the radius squared. So find the equation of the circle with center -2, 6 and radius 4. Well, writing it in this format, my center HK is going to be -2, 6. My radius is 4. So my equation is x minus -2 squared plus y minus 6 squared equals 4 squared. So x plus 2 squared plus y minus 6 squared equals 16 as my equation of the circle. Okay, nice and straightforward, really. So moving on then to look at our other potential option for the equation of a circle is this kind of longer form, and this is sometimes referred to as the general form. Okay, this is like our general form, or the general equation of the circle. And where this, I suppose, form comes from really is if we take our answer from the previous part, even just looking at that example, with the x minus h and y minus k format, if we were to expand those brackets and multiply those out, we would end up with this format that we have here, this long form version. So that is x squared plus y squared plus 2gx plus 2fy plus c equals 0, where my center is now minus g minus f, and my radius is root g squared plus f squared minus c. Okay, once again, coefficient of x squared and y squared must be 1. The main reason for that being when we want to identify the center or identify the radius, we have to have that coefficient of 1. We may choose to write it in a format where we've maybe multiplied across to eliminate a fraction or something like that, so that x and y do have a coefficient, but it's more that if we need to use like the center being g and f, we need to ensure that x squared and y squared have a coefficient of 1 before we do that. So looking at the example, find the equation of circle with center 4 minus 3 and radius 6. Give the equation in the form x squared plus y squared plus 2gx plus 2fy plus c. So looking at this equation here, I have my center of 4 minus 3, and I'm going to note that for this long version, the center is always given as minus g minus f, and it's important here that we include the fact, I suppose, that that is negative. Okay, so it's always minus g minus f. And again, this can kind of play, or it can be a bit tricky to do with signs here just to ensure that everything's correct all the time. But it's really just something to watch out for in all cases here, that you're definitely allocating the right sign, because you can see in the actual format of the circle, it's just g and f. So we will need to kind of adjust our signs here accordingly. So if minus g is 4, then g is minus 4, and if minus f is minus 3, then f is just 3. Okay, so that's setting me up for the g and f part here. The last thing I need is c, and to do that I'm going to use the radius. So we have a kind of longer formula for radius here in this format of the circle, and it's g squared plus f squared minus c, and I know in this case that the answer is 6. I can sub in my values here. Now, if I hadn't worked out the actual value for, I suppose, g and f in that kind of positive sense, it would actually make no difference to my calculation here anyway. I'm going to square both sides there as well. So I have 36 here minus c equals, let's adjust that, so 36 minus 16 minus 9 gives me 11. So c equals minus 11. So filling all of this into my equation, x squared plus y squared plus 2 minus 4x plus 2, 3y minus 11 equals 0, and just multiplying anything that I can there. So minus 8x plus 6y minus 11 equals 0. Okay, and we end up with our nice equation of the circle there. And as I said already, if we were to write that equation in the other format that we had, so that minus h or x squared, x minus h squared, y minus k squared format equals radius squared, we could show that by multiplying this out, I would end up with the same equation. So let's just have a look at that there. So just finalizing that, or writing it out in that exact format here, and then adjusting. So x squared minus 8x plus 16 plus y squared plus 6y plus 9 equals 36. So x squared plus y squared minus 8x plus 6y, and we get our minus 11 here. We end up with the same format of the circle. So showing that those two, I suppose, equations of our circle there are quite related. I suppose one more thing to note here, and particularly I suppose with this first format of the circle, is even just where this kind of comes from. If we think about a general circle here with a center of hk, and I pick any point on my circle and I call this point xy, well then the distance between these 2 points would be the radius of my circle. And if we apply our distance formula, x minus h squared y minus k squared, that should be equal to the distance, which we're saying here is the radius, and by squaring both sides we can see that we end up with that equation of the circle there in that correct format. Okay, so just showing, I suppose, how all of these are derived or related, and I suppose this could be quite important for us as well when we come to later points and we're looking at maybe where points are on the circle, or whether points are kind of inside or outside the circle. It could be worthwhile for us to just have that idea of where this equation kind of comes from. So let's just look, I suppose, at this last example here, and then we'll get into some exam questions. Find the center and radius of the circle with equation 9x squared plus 9y squared minus 6x plus 18y plus 1. So as I said already, the first thing we want to do really here is to eliminate that coefficient of 9, because only then can we apply what we know about this equation of the circle here. So 6 over 9x plus 18 over 9y plus 1 over 9 equals 0. And I can reduce these down a little bit as well. So x squared plus y squared minus 2 over 3x plus 2y plus 1 over 9 equals 0. So my center, I know that my coefficient of x in this long format, the coefficient of x is 2g. So 2g is minus 2 over 3, which means g is minus 1 over 3. And for my center, I'm going to be using minus g. So let's just set that up fully as well. Similarly then, coefficient of y here is going to be 2f, which is 2. F is 1, so minus f is minus 1. So my center here is going to be 1 over 3 minus 1. Okay, it's very important here for these questions that we are able to take the center and take the radius out of this equation of the circle, because that comes up in quite a lot of these questions here. The last thing we need to do then is just to find the radius. So my radius is square root of g squared plus f squared minus c. So I suppose that's why we tend to find g and f first. So minus 1 over 3 plus 1 squared minus c, and here c is just 1. So that's going to be 1 over 9 plus 1, oh sorry, c here is 1 over 9, of course, because we're taking this other, I suppose, the version after we've divided here. So that's going to be 1 over 9 minus 1 over 9, which is square root of 1, which is just 1. Okay, so center here and radius of 1. Center of 1 over 3 minus 1, radius of 1. Okay, so looking into some of the exam questions then, so just kind of basic setting up equations of circles here. The circle C has equation x squared plus y squared minus 2x plus ay plus k equals 0, where k is an element of 4, the radius is 5 root 3, find the value of k. So I'm looking at that question, I'm saying, well, in terms of my circle here, k is, or corresponds with that letter of C, so that's going to be used when I'm finding the radius. So I need to find g and f first here. So looking at the coefficient of x, I know the coefficient of x is always 2g, so 2g is minus 2, g is minus 1, so therefore minus g is 1. Similarly then 2f is 8, f is 4, so minus f is minus 4. Okay, so that's going to be important for my center here. I'm not actually asked to find the center here, but it's always good to kind of just find those things to see what we'll be working with here. I suppose this was a first part of a question, so there may have been more. So radius is g squared plus f squared minus c. So filling in the things that we can here, we know g is minus 1, we know f is 4, and k is going to go in place of c there. Okay, so filling this out, I get 1 plus 16 minus k, and I actually know in this case that this has an overall answer of 5 root 3. So I have root 17 minus k equals 5 root 3. I'm going to square both sides to eliminate that square root here, so I get 17 minus k. 5 root 3, if I'm a bit unsure of, I might want to type into my calculator just to be sure that I square it right. I'm using brackets here as well to make sure that everything's squared appropriately. I'm getting 75 minus k equals 75 minus 17, which is 58. So k is equal to minus 58. So k is equal to minus 58 here. And I was just asked to find the value of k, so I can stop my conclusion there. Looking at the next question, A and B are the endpoints of the diameter of a circle. So let's just kind of look at what we're looking at here. So I have A here, I have B here, I have center here, and I have a line straight through. Let's adjust that there. I have a line straight through from A to B. Okay, so what I'm noticing straight away is half that distance from A to B is going to be the radius of my circle. Okay, I can also see here that if this is the radius and this is the radius, then this point is actually splitting those 2 points directly in half, and thus that's going to be the midpoint of A and B there. Okay, so that's going to be the center. So half that distance is the radius, and the midpoint is going to be the center. Okay, so we just start by finding, I suppose, whichever one we want to get first. Let's get the distance maybe between A and B first. So that's the square root of 1 minus 1. Why am I starting with the y's? Let's start with the x's first, I suppose. So x2 minus x1. So we'll do minus 1 minus 3 squared plus minus 3 minus 1 squared. So that's minus 4 squared plus minus 4 squared. 16 plus 16, which is root 32, and that can in fact break down. If I get my calculator here, just have a little look. Root 32 is 4 root 2. So I know my radius is half of that, so half of 4 root 2, which of course is 2 root 2. So I know my radius now is going to be 2 root 2, that's this distance here, or of course this distance here as well. The midpoint then, I want to get the midpoint for A and B as well, so minus 1 plus 3 over 2, and minus 3 plus 1 over 2. So that's going to be 2 over 2 minus 2 over 2, which is 1 minus 1. And this is my center here. Okay, now I'm asked to find the equation of the circle when I have this information. Okay, and the information I have here, I suppose, is center and radius. When I have this information, I will always default to my x minus h squared and y minus k squared. And the reason for that's fairly simple. It just saves me finding the value of c. That's really all that it is. It saves me finding the value of c. I can substrate into this equation just with the information that I have already. So that's x minus 1 squared plus y plus 1 squared equals 2 root 2 squared. And simplifying that there, or multiplying everything out, y plus 1 squared equals 8. That's my overall equation of the circle there. Okay, so again, just kind of making things easier for yourself. These two equations of the circle, unless they specify a particular one that they want you to use, it kind of is just dealer's choice, whichever you decide to choose. I would always just look at what information do I have, and out of that information, which is going to be easiest for me to sub into. Okay, last little point here then, two circles C1 and C2 have their centres on the x-axis. Each circle has a radius of 5 units. The point 1,4 lies on each circle. Find the equation of C1 and the equation of C2. Okay. So we're looking at some sort of case here where if this is the x-axis, there's some point that both circles have in common, which is the point 1,4. So that might be the point there. The circles might look something like that. Okay, we obviously don't know exactly what the situation is. What I'm going to take advantage of here is that from the center of each circle to this point 1,4 is going to be the radius of each circle. And I know in this case that the radius of each circle is 5 units. Okay, since the center is on the x-axis, that's going to mean that y is equal to 0. So the center is going to be something 0. Okay, so for both questions, the center is just going to be something 0. Okay, the distance to that point 1,4 should be equal to the radius, which is 5. So let's just have a look and see if we can solve our question now just using that information. So x minus 1 squared plus 0 minus 4 squared should be equal to 4. So x minus 1 all squared plus minus 4 squared equals 5. So I'm going to save this bracket until I've inevitably decided to maybe square both sides here. So let's square both sides now. So x minus 1 squared plus 16 equals 25. X minus 2x plus 1 equals 9. Bringing all that over, then x squared minus 2x minus 8 equals 0. And I can solve that then to get my overall answer. So just solving my quadratic there is going to give me x equals 4 and x equals 2. Okay, so I've got my two answers for x here, which means my center for one of my circles is going to be 4, 0, and the center for the second circle is going to be 2, 0. Both have a radius of 5. So as we had in the last case, once I know what my radius is, I can use this shorter format for the equation of the circle. And noting here, we have two nice circles here which have a y coordinate for their center of 0, so we just end up with that y squared then when we write out the equation, and my two equations of my circle. So the main thing coming up here really just generally is being able to use those two formats for the equation of the circle quite fluently, being able to pick out the center and the radius depending which format they give. I suppose the particular one that takes a bit of practice or that takes a bit of work, and the one that they obviously like to use, is the x squared plus y squared plus 2g x 2fy, that idea, being able to find g and f, and making sure that you know in that format of the circle that the center is always minus g minus f, making sure that you kind of negate those values there, and that's going to keep everything then straight when we come to those later questions.